We take up the second problem. If u equals x to the power of y, then verify that delta square u by delta x delta y equals delta square u by delta y delta x. Now you have to understand the notation properly. What he is asking, you convert it into simple notations. Observe here. Delta square u by delta x delta y, I told you in the beginning itself, in the definition of symbols of partial differentiation, delta square u by delta x delta y means first you take delta u by delta y, the meaning I have explained. Then again you differentiate delta u by delta y with respect to x. Therefore, with respect to partial differentiation with respect to x means delta by delta x. That's equal to, now delta square u by delta y delta x means take delta u by delta x. Right. Now delta square u by delta y delta x symbol, remember, it means again differentiate with respect to y partially. That means write delta by delta y. Or if you make it more simple, observe here, u is there, u. Delta by delta y of u means differentiate u with respect to y. Therefore it becomes uy. That uy you are differentiating with respect to x partially. Y, delta by delta x symbol is there. With respect to x, when you differentiate, it becomes u by x. That's equal to, same thing here. Delta u by delta x means ux. You are differentiating delta u by delta x. That means you are differentiating ux again partially with respect to y. Because delta by delta y is there, it means differentiate partially with respect to y. Therefore, take ux and differentiate with respect to y. So what he is asking is, in this language, prove that uyx equal to uxy. Now, we'll again proceed that. We will follow in the same way. So, see LHS. We first find LHS. If you want to find LHS, you have to take u. U is given. Take it. Given u equals x to the power of y. Next, slowly you understand. First you have to find uy. When uy answer comes, that answer you differentiate partially with respect to x. You will get uyx. So first we will find uy. We find uy. So what is the meaning of uy? Take u and differentiate partially with respect to y. Before that, you have to remember one formula from PUC. d by dx of a to the power of x is a to the power of x into log a. This formula you have to by heart remember from PUC because sometimes it is used in this problem. When you differentiate a to the power of x, then answer is a to the power of x into log a. Now we will use this formula. Uy. What is the meaning of uy? Take u and partially differentiate u with respect to y. When you are partially differentiating with respect to y, in the mind, be careful. Any x term is like a constant. Here x term is x. So I make it x term is x. It is like a constant. So it is like a constant a. That means it is like a to the power of y. So when you differentiate a to the power of y with respect to y, answer is, look here, a to the power of y into log a. Therefore, here it is x to the power of y into, instead of a, you have what? X into log x. Therefore, when you differentiate u with respect to y, any x term is like a constant number. Therefore, when you differentiate with respect to y, because any x term is like a number, answer is x to the power of y into log x. So, uy is over. Now, uyx, we find uyx. What is the meaning of uyx? Take uy. Uy is here. Differentiate uy partially with respect to x. Be careful. When you are differentiating partially with respect to x, in the mind, any y term should be kept as constant. Now, here you should think carefully before differentiation. Partial differentiation is done. You are differentiating with respect to x, you know. Observe, first term contains x and second term contains also x. If first term contains x, second term also contains x, you should apply product rule. This is like first function into second function. So product rule says first function into differential of second function plus second function into differential of first function with respect to x. So first function is x to the power of y into differential of second function x to the power of y with first function x to the power of y here into differential of second function log x. Log x, when you differentiate the second function with respect to x, it is 1 by x plus second function log x into differential of first function x to the power of y with respect to x. Because you are partially differentiating with respect to x, any y term here is like a number. So it is like x to the power of some number, like x cube, x square, like that. So x to the power of y, when you differentiate, answer is yx to the power of y minus 1. Yx to the power of y minus 1. Or if you write it properly, 1 by x means x to the power of minus 1. Therefore, you get x to the power of y into x to the power of minus 1 plus y log x plus y log x into x to the power of y minus 1. Now, if you write it properly, you get u by x equals y to the power of x to the power of y, x to the power of minus 1 means x to the power of y minus 1. Here also x to the power of y minus 1 is there. You can take x to the power of y minus 1 as common factor. Again I repeat, x to the power of y into x to the power of minus 1. This is like a to the power of m into a to the power of n index class. Therefore, you get x to the power of y minus 1. Here also x to the power of y minus 1. Remaining here is 1 plus here it is y log x. So the answer is u by x equals this one. So what is u by x? Look here in the problem, it is LHS. Next, we find RHS. We find RHS. So if you want to find the RHS here, ux you want to find. So take u. So take u. U is given. What is u? It is x to the power of y. Take u. You want ux. Therefore, we find ux. What is ux? Partial derivative of u with respect to x. So you differentiate u with respect to x. Be careful. When you are differentiating u with respect to x, any y term is like a number. So here y means it is like a number. It is like x to the power of some number, like x cube, x square, etc. So you differentiate u with respect to x partially, because any y term is like a number. X to the power of any number is that number, x to the power of that number minus 1. So x to the power of y, you differentiate with respect to x, because y term is constant, you get y into x to the power of y minus 1. So this is ux. Now what you want is uxy. Therefore, take ux and differentiate ux partially with respect to y. So ux becomes uxy. So ux, this value I am taking and differentiating both sides with respect to y. So ux, when you differentiate with respect to y, ux becomes uxy. So right side also if you differentiate partially with respect to y. So right side is yx to the power of y minus 1. Remember, you are differentiating with respect to y partially. So you should write delta y of this. You are differentiating yx to the power of y minus 1 with respect to y. Now observe here, first term contains y. Second term also contains y. It contains y symbol. Therefore, first term contains y. Second term contains y. Both terms contains y. It is the product of first term and second term. Therefore, we should differentiate using product rule with respect to y. So, product rule means first function y into differential of x to the power of y minus 1 with respect to y. Because you are differentiating with respect to y, any x term is like a constant. So, x to the power of y minus 1, when you differentiate, you get x to the power of y minus 1 into log x, because it is a constant, plus second term, that is x to the power of y minus 1 into differential of first term y with respect to y. It is 1. Now observe here, y log x, it is there, x to the power of y minus 1, here also x to the power of y minus 1. Therefore, we can take x to the power of y minus 1 as common factor. What I am doing here is x to the power 5 minus 1 is there. Here also x to the power 5 minus 1 is there. This x to the power 5 minus 1, this x to the power 5 minus 1 have taken common factor. Remaining is y log x plus 1. So remaining is y log x plus 1. Therefore, you can see here that LHS equals u by x. U by x. And see here, uxy and uyx values. In ux, x to the power 5 minus 1. In uxy also, x to the power 5 minus 1. In uyx, y log x plus 1. In uxy also, y log x plus 1. So what did we say? Uyx is equal to uxy. Therefore, uyx is equal to uxy. But uxy is nothing but our RHS. Therefore, we have proved that LHS equals R. These two problems show you how to handle a given problem using the concept of partial differentiation with respect to x or with respect to y. We have to do the problem very slowly and understand the subject.